All right, so let's look at this. We're going to look at a few examples really, where we're going to use a couple of examples to illustrate how we can um, use a graphical approach to solve linear programming type of problems, right? Next week, we'll deal with what they call the simplex method, and we have various versions of that as well. It's a little more complex. I don't know why they name it simplex. It's not as simple. Okay. Um, we'll get to that. But this is a much easier approach to solve those problems. So here is one. So this factory is producing two types of gadgets, a regular type and a premium type. So we give you some details there. So the two gadgets, they require some amount of assembly and then some amount of finishing, And well, they have some what they call constraints, some conditions that the factory just has to work with. They say that there are 12 hours each operation. Right? That's the assembly business and the finishing, right? They say the regular gadget requires 1 hour of assembly, 2 hours of finishing, while the premium gadget, 2 hours of assembly, 1 hour of finishing, right? And they have to make 7 body, right? At most 7 body. Sorry, I think I read that wrong. They can make at most 7 right? Which means they can't exceed that. Perhaps because of limitations and so on. And then they give you some profit information. You make $20 for every regular gadget they make and $30 for a premium one. And you want to know how many of each, should be manufactured to maximize profit, right? So, of course, some textbooks and so will kind of look at the problem or approach the problem a little differently. Right? This one, they start with the objective function at the beginning. Like the objective is, okay, this is your profit equation, 20x plus 30y, right? That's what you see here. Oh my gadget. So this here, starting off with this, right? And some would normally introduce this a little later. Doesn't matter, right? And you want to notice they use the word, you want to maximize profit. So you want to find the maximum value that this can take on, maximum value that this expression can take on, given some other conditions, right? That's if this was like unbounded, there's no constraint, there's no maximum value for this, right? X can be infinity, Y can be infinity, but you have to work with certain constraints, and these are some of the constraints. You can't make more than 7 of the 2 gadgets. So if X is the number of regular gadgets, Y is the number of premium gadgets, the sum can't be greater than 7. It's either 7 or less, right? And then there's some constraints with assembly. I think they're 12 hours each operation. So there are only 12 hours for assembly, 12 hours for finishing. So the first gadget, that's the regular, requires 1 hour of assembly, 2 hours of finishing. But then you add up, right? If you make X regular and Y premium, you add up all the hours for assembly, it mustn't be greater than that. Same thing here. The premium gadget takes 2 hours of assembly, 1 hour of finishing, right? And if you make x of it, what is it? X of the regular one. And did I get that right? I think this has to do with the assembly part, right? So it takes 1 hour to assemble the what is it called? The regular thing. 2 hours to assemble the premium one. Here, you take 2 hours to assemble the premium one and 1 hour to uh, assemble, not assemble, this is finishing one. 2 hours to finish the regular, 1 hour to finish the what is it about? The premium. However, the two conditions, notice, they only have 12 hours for each operation. So that those are what you call constraints. Constraints. Right? You all are following that so far? You all are following the thing?
Yes, sir.
Yes.
Up a little. You have some other these here are kind of ever present conditions that when you have to make at least one of each of the gadgets, you know, that's maybe market demand that you have both of them. You know, there's like there's things like that where you know you say, man, if you're making more money and the premium, we just make premium. Go after the poor people, you know. Understand? You got to balance the cheaper gadget with the more expensive one, and you can do one and not the other. Right? Yeah. Like I tell you, there's a hair gel that I use, not a gel, it's a Vaseline I use on my hair, named Softy, right? Softy. And for some reason, when you check, there's a what do you call it? Olive oil Softy that we have. And guess what? This olive oil Softy, as soon as it comes on the shelf, it's gone. And I asked the question, why they just don't make plenty of this? Just fill the shelf with it if it's the one that goes. Yet when you go to the shelf, there's always the other. There's always the other. You know? And one wonder why they don't just make plenty of this one. Right? That's the same thing I'm telling you here. I don't know if the premium one making more money, why not just make that one? Right? But you know, manufacturers have their reasons, and y'all are going to get into that line of thing later on. All right. So this captures all the information. This is your profit equation, or about the objective equation. You want to maximize that, but X and Y can't take on just any value. The X and Y value must fall within these constraints. Right? So what we're gonna do now is we're gonna try to graph. We're gonna try to graph these inequalities, right? The conditions if X plus Y is less than or equal to 7, X plus 2Y is less than or equal to 12, 2X plus Y is less than or equal to 12, X is greater than or equal to 0, Y is greater than or equal to 0. So you're gonna put all of that in a graph, right? And that's what the various graphs will look like, right? X plus Y is less than or equal to 7. So this is the line. Probably yeah. The line X plus Y equal to 7 is this line here. Right? And the region below it is what satisfies the inequality. You know, let me explain how we do that. If you want to draw the line X plus Y equals 7, you can make up a little table. You want to plot Y Plus x plus y equals 7. So you put x here, you put y here. Give x the value 0. Then y will be 7. Give y 0. Then x will be 7. So you have 2 points there. You have 0, 7, and 7, 0. And that's your line right here. Down here is going to be 7, 0. And down here is going to be 0, 7. Right? And you draw through the line, and you get the line x plus y equals 7. This red that I'm showing you, right? And how do you know which part satisfies the inequality x plus y is less than or equal to 7? Then you choose a point either below or above the line, right? And check to see if it satisfies the inequality. So let's say I use 0, 0. And I'm using this point because it's below the line and it kind of represents all the points below the line. So I'm using 0, 0. What happens? 0 plus 0 is less than 7, right? So therefore, the region below here satisfies the equality x plus y is less than 7. You repeat the same procedure for x plus 2y is less than 12, 2x plus y is less than 12, right? You do it for that. X is greater than 0 is just the y-axis, and y is greater than 0 is the x-axis, right? And where all these shaded regions intersect, you call that your feasible region, right? And there is this theorem that the maximum for this objective function will occur at one of the corner points, right? When you make up this little polygon like that you have here, you take the corner points here, 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 right? You get 1, 2, 3, 4, 5 corner points. You read them out, right? You read them out. And people actually give you them. You read all of them out. So what you do next? Oh, that's missing up things. All right, let me erase all of it. So you read them out, and what we do now is we substitute those points, we substitute them in the, remember the profit equation, then to x plus thought to y, we put them in. So the points were 0, 0, 0, 6, 2, 5, 5, 6, 0. And you put them in place of x and y. You work out all the time. And the profit equation gives you what, 190 as the maximum. The maximum number. That
Yes,
happens.
sir.
Okay, you have a question, Tushan?
No, sir. They just saying yes. This is the maximum number.
Yeah, so it happens when you make 2 of the regular budget and 5 of the premium one. Right? Let's say in your little test that you're gonna have, you don't quite get this drawing of this graph by hand. That's not a problem. Let me quickly go to Desmos. I'm gonna go to Desmos and show you how it's done, right? So I need to write down the creative. Give me a second, I have to write them. What were you creating? So I have x plus y equals 7, that's not equal 7, x plus 2y, so 2x plus y, that's not equal to 12. But we know the others. X is greater than or equal to 0, y is greater than or equal to 0, right? Let me see. I'm gonna stop sharing from one, okay? I need to go and open this. And open my window because it's getting hot. There's our graph here. Graphing x plus 7 is less than or equal to, no, sorry, x plus y. Right? I think there was a guy who was doing some neat trick. And he was getting rid of the negative part. Let me see if I can do it. Uh, some time, that is why. And then there's another one. Yeah, I think that's a way of getting rid of the negative part, right? So your line really is x plus y is greater than 7, right? Yeah. What was the next one? You want, it takes some doing, right? But x plus 2y. Yes. Well, right. So I think now for you to get, we'll probably put back all of these conditions in. Try to allow me to copy. Control C, Control V, and I also can put this here. Control C, Control V. It takes some doing to get rid of this like this red part here. I actually have to put, there's another condition I have to put to take out that and so. Uh, yeah, something like that you have to do. Something like just, yeah. You don't care about it. You just want the intersection like there. You want the intersection there, you want the intersection there. Otherwise, I'm not seeing the intersection. I'm having some trouble doing that. What's going on? I wanted this point here. That point here. You have to read it off basically, because but you're supposed to click here. I wanted these conditions are now affecting voting plus y. Yes, until one. You have to put all of this control C. I put in here. Control C. I want to get rid of this piece and this piece because your feasible region um, your feasible region here is in this. The feasible region is in here, along here, along here. This is right. This is your feasible region. I need to get rid of that and get rid